The requirement for a 3-foot clearance zone in front of an electrical panel, as detailed in the National Electrical Code, or NEC, does not apply when a panel is situated within a manhole. The primary purpose of this clearance requirement is to ensure that personnel have sufficient space to safely access and work on electrical equipment while it is energized. This includes tasks such as troubleshooting, maintenance, and repairs. The NEC mandates these clearances to protect workers from potential electrical hazards like shock and arc flash. These hazards are significantly reduced or eliminated when the power to the equipment is intentionally shut off before any work begins. In the context of an electrical panel installed in a manhole, standard operating procedures typically necessitate de-energizing the panel before any entry or work is performed within the confined space. This is due to the inherent safety risks associated with working in such an environment, including limited access, potential for atmospheric hazards, and the presence of other utilities. Given that the electrical panel is de-energized prior to access, the rationale behind the 3-foot clearance requirement diminishes. The potential for electrical hazards is significantly reduced, and the need for immediate access to de-energize the equipment in an emergency is no longer a primary concern. The NEC addresses specific installations and environments, often providing exceptions or modifications to general rules based on the unique characteristics of the situation. In the case of manholes, the confined space and controlled access procedures justify a deviation from the standard clearance requirements for electrical panels. The decision to waive the 3-foot clearance requirement in this scenario is based on a risk assessment that considers the de-energized state of the equipment during access, the controlled environment of the manhole, and the safety protocols in place for working in confined spaces. It is essential to emphasize that this exception does not imply a disregard for safety. Instead, it reflects a practical application of the NEC, adapting the rules to the specific conditions of the installation while maintaining an acceptable level of safety for qualified personnel. The NEC provides detailed guidelines and tables that specify the required working clearances for electrical equipment operating at various voltage levels. These clearances are measured from the front of the equipment to any grounded surface or other obstruction. The specific clearance required depends on the voltage level of the equipment and the presence of exposed live parts. For example, for equipment operating at 600 volts or less, the NEC typically requires a minimum working clearance of 3 feet. However, this clearance may be increased depending on the specific configuration of the installation and the presence of any hazards. The NEC also addresses the requirements for working space around electrical equipment. This includes provisions for adequate illumination, ventilation, and access. The working space must be sufficient to allow personnel to safely and effectively perform their tasks. In addition to the NEC, other safety standards and regulations may apply to electrical installations in manholes. These may include requirements for confined space entry, personal protective equipment, and lockout/tagout procedures. It is important to consult all applicable codes and standards to ensure that the installation is safe and compliant. The exception to the 3-foot clearance rule for electrical panels in manholes is not a blanket waiver. It is contingent upon the implementation of appropriate safety procedures and controls. These may include the following: firstly, a written safety plan that outlines the procedures for working on electrical equipment in manholes. Secondly, training for personnel on the hazards of working in confined spaces and around electrical equipment. Thirdly, the use of appropriate personal protective equipment, such as insulated gloves and eye protection. Fourthly, the implementation of a lockout/tagout procedure to ensure that the equipment is de-energized before work begins. And fifthly, the presence of a qualified person to supervise the work and ensure that all safety procedures are followed. In summary, the 3-foot clearance requirement for electrical panels does not apply when the panel is located in a manhole and the power is turned off before access. This exception is based on the reduced risk of electrical hazards and the implementation of appropriate safety procedures. However, it is important to consult all applicable codes and standards to ensure that the installation is safe and compliant. The NEC is a comprehensive set of guidelines designed to ensure the safe installation and operation of electrical systems. It addresses a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect the latest advances in technology and safety practices. It is essential for electrical professionals to stay up to date on the latest edition of the NEC to ensure that their work is safe and compliant. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is legally required in many areas. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. In addition to the NEC, other organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, also develop standards and guidelines related to electrical safety. These standards may provide more specific guidance on certain topics, such as arc flash protection and grounding. It is important to consult all applicable codes and standards to ensure that the installation is safe and compliant. The design and installation of electrical systems in manholes require careful consideration of the unique challenges posed by this environment. These challenges include limited space, potential for flooding, and the presence of corrosive substances. To address these challenges, electrical equipment used in manholes should be specifically designed for this environment. This may include features such as watertight enclosures, corrosion-resistant materials, and explosion-proof construction. Wiring methods used in manholes should also be carefully selected to ensure that they are suitable for the environment. This may include the use of cable that is rated for direct burial or cable that is installed in conduit. Grounding is also a critical consideration for electrical systems in manholes. Proper grounding helps to prevent electrical shock and equipment damage. The grounding system should be designed to provide a low impedance path for fault current to flow back to the source. Regular inspection and maintenance are essential for electrical systems in manholes. These inspections should be performed by qualified personnel who are trained to identify potential hazards. Maintenance tasks may include cleaning equipment, tightening connections, and replacing damaged components. By following these guidelines, it is possible to design, install, and maintain electrical systems in manholes that are safe and reliable. The information provided here is for general guidance only and should not be considered a substitute for professional advice. It is essential to consult with a qualified electrical engineer or contractor to ensure that the installation is compliant with all applicable codes and standards. The interpretation and application of the NEC can be complex, and it is important to have a thorough understanding of the code before making any decisions. In addition, local codes and regulations may vary, so it is important to check with the local authority having jurisdiction to ensure compliance. The NEC is a living document that is constantly evolving to reflect changes in technology and safety practices. It is important to stay up to date on the latest edition of the NEC to ensure that the installation is safer and compliant. There are many resources available to help electrical professionals stay up to date on the NEC. These include training courses, seminars, and publications. The NEC is an essential tool for ensuring the safe installation and operation of electrical systems. By following the guidelines in the NEC, it is possible to protect workers from electrical hazards and prevent equipment damage. The NEC is a valuable resource for electrical professionals, and it is important to use it effectively. In conclusion, while the NEC generally requires a 3-foot clearance in front of electrical panels for safety during maintenance and servicing, this requirement is waived when the panel is located in a manhole, provided that the power to the panel is turned off before any access or work is performed. This exception is based on the principle that de-energizing the equipment eliminates the electrical hazards that the clearance requirement is intended to mitigate. However, it is crucial to adhere to strict safety protocols and confined space entry procedures to ensure the safety of personnel working in the manhole environment. The NEC provides a framework for electrical safety, and its application must be tailored to the specific circumstances of each installation, balancing safety with practicality. Understanding the rationale behind the code requirements and the potential exceptions is essential for electrical professionals to make informed decisions and ensure compliance with applicable regulations. The NEC, specifically Article 110.26, addresses working space about electrical equipment. This section details the requirements for clear working space in the vicinity of electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. The intent is to provide sufficient space for personnel to safely perform these tasks. However, as previously discussed, this requirement is not strictly enforced when the electrical panel is located in a manhole and is de-energized before access. Article 110.26 specifies the depth of the working space in the direction of access to the equipment. This depth is determined by the voltage to ground of the electrical equipment and the conditions present in the working space. The conditions are typically categorized as firstly condition 1, where there are exposed live parts on one side and no live or grounded parts on the other side of the working space, or where exposed live parts are on both sides but are effectively protected by insulation or other means. Secondly, condition 2, where there are exposed live parts on one side and grounded parts on the other side of the working space. And thirdly, condition 3, where there are exposed live parts on both sides of the working space that are not effectively protected by insulation or other means. The depth of the working space increases as the voltage to ground increases and as the conditions become more hazardous. For example, for equipment operating at 150 volts to ground or less, the required working space depth is 3 feet for condition 1, 3 feet for condition 2, and 3 feet for condition 3. However, for equipment operating at 601 volts to ground to 2500 volts to ground, the required working space depth increases to 3 feet for condition 1, 4 feet for condition 2, and 5 feet for condition 3. Article 110.26b specifies the width of the working space. The width must be at least 30 inches or the width of the equipment, whichever is greater. The working space must be clear and unobstructed, and it must extend from the floor to a height of at least 6 feet 6 inches or the height of the equipment, whichever is greater. Article 110.26c specifies the height of the working space. As mentioned previously, the working space must extend from the floor to a height of at least 6 feet 6 inches or the height of the equipment, whichever is greater. Article 110.26d addresses access and egress. The working space must have adequate access and egress. There must be at least one entrance to the working space, and the entrance must be of sufficient size to allow personnel to safely enter and exit the space. If the working space contains equipment rated at 1200 amps or more and over 6 feet wide, there must be an entrance at each end of the working space. Article 110.26e addresses illumination. The working space must be adequately illuminated. The minimum illumination level is 10-foot candles measured at the working surface. Article 110.26f addresses headroom. The minimum headroom in working space is around service equipment, switchboards, panel boards, or motor control centers shall be 6 feet 6 inches.